Good morning, student. Today, let's start today's class. Okay. Today we will study about passive space conditioning. Okay. Passive space conditioning. Okay. What is passive space conditioning? Conditioning. That means the in this that means the situation where we use solar radiation to condition our room temperature or building temperature is called passive space conditioning. Okay. And in the 1917, passive solar energy was used for concepts that could be used in building design for increasing solar heat in a building during winter and to minimize the entry of the solar radiation inside a building during summer. In addition, the role of wind movement, trees, and it's छोड़ो. The use of fixed and movable shading device is also contained in the definition of passive solar energy. To use sun during the day in the winter and to create shade during the night in the winter or day in the summer, there are several building design. That means the passive solar energy, that means by using solar energy, how we can uh, control, we can warm our room in winter, and how we can cool our room in summer. That's the concept behind the passive space conditioning. Conditioning means, I mean, we use air condition AC, air condition. That means we control the air temperature inside our room by using AC. Okay, that's like in passive solar conditioning or passive space conditioning, we use the temperature of our space or room or building by using solar radiation. Okay, then let's see the principles of that solar spacing conditioning, space conditioning. Okay, principles. The principles means why we use the solar space conditioning and how we use the solar space conditioning. Okay, the principle. The objectives of using solar space concept for solar passive concepts for space heating are as follows. What is the object? What is the aim behind the using of uh, solar passive radiation for space heating? To gain as much solar radiation as possible. That means we use we use uh, we use we use such design which uses as much possible radiation of solar. Okay, that to minimize transmission losses from wall and window, and minimize the losses from window and wall. Okay, this to minimize that, to prevent the losses. Okay, to minimize ventilation and inflation in infiltration. Okay, infiltration, that means ventilation ରେ ଯେଉଁ ଲସ୍ ହେଉଛି ହେଲା, ଆମର ଭେଣ୍ଟିଲେସନ୍ ଯେଉଁ ଏୟାର ଦ୍ୱାରା ଲସ୍ ହେଉଛି ତାକୁ ବି ମିନିମାଇଜ୍ କରାଯିବ. To minimize losses through suitable building construction and direct air movement towards the region of demand. That means the building construction, suitable building construction and directed air movement को minimize କରିବା ହେଲା. ମାନେ ଏମିତି building construction କରିବା ଯେଉଁ ଦ୍ୱାରା କି ଆମର air movement ଯେଉଁ ଦ୍ୱାରା losses ହେଉଛି ସେଟା minimize ହେଇଯିବ ହେଲା. ନେକ୍ସଟ ଆସିବା the important physical process as far as the gain of solar radiation is concerned are schematically represented here. okay, this figure, okay. That means the incident solar radiation on the transparent portion. That means here what happened, no, here what happened, no, the solar radiation fall on the transparent side of the building. That is, it may be window or it may be your door which covered with clear glass, okay. So this the solar radiation, okay, fall on the transparent side of the building, and all and all of the radiation not going through the transparent mm, partition, some of are reflected back, okay. So we get some radiation inside our, this is our room, okay, inside our room, okay. Then what happened, due to convection, process or natural convection process, the air inside our room get heated. That means the by the radiation, or by the solar radiation, the air of our room heated, convection by using convection technique. Convection means the hot air transfer, when convection process is called, convection process is when the solar radiate on the air or air surface, that air surface heated and get lighter and it goes upward, okay. Then the cold air which is heavier, that that come downward, okay, and heated by the solar radiation and gets lighter and goes upward. That circle, this cycle is called convection. Heated going upward and cold air going downward, and heated going upward and cold air going downward. This cycle is called convection process, okay. And also there is a additional storage of heat, okay. This additional storage of heat store some energy or some heat radiation, okay. This is the this is called this is this portion of the wall is thermal storage in house, okay. This portion of the wall is designed as such that when solar radiation fall on that wall or that portion, this store energy or heat energy inside additional storage, okay. And we use that additional storage in a winter night, okay. And here the ventilation is process, the ventilated process is done, okay. And non-sanitary transmission losses, there is two losses, non-stationary transmission losses and ventilation and inflation losses, okay. Then what happened, the sum of all these energy components within the building in interact themselves, interact thermally with the surrounding in the following ways. That means all the component, they here all the component of the building, losses, ventilation losses, additional storage, everything, reflection, convection, all the all the component of the building interact themselves within the surrounding in the following ways. Non-stationary heat condition through the building envelope means the building envelope the non-stationary heat condition. Okay, non-stationary heat means the heat condition which is not constant. Okay, then long wave radiation exchange, then sensible and latent heat transfer as a result of ventilation and inflation. The principal concept of passive solar heating consists of the following tasks. The principle or our aim which we want to fulfill by using these three works. Okay, first work is collection of irradiation irradiated energy. That means the scattering of rays, collecting this scattering of rays. Okay, or energy from that scattering of sun rays. Okay, storage the collected energy, then store that collected energy. Okay, then utilization of collected energy in a controlled fashion so that the usual thermal comfort scale can be maintained. That means, and that storing energy which we store from scattering of solar radiation used them in a controlled manner, in a need in a in a in a needful manner. That means how much that much we need, we use that much. Okay, or how much we need, we use that much of energy. Okay, by this process we use we can maintain our uh, and maintain our heat. Okay, inside our building. Okay, in order to fulfill the last two tasks, that means storing of collected energy and utilization of collected energy in a controlled fashion, it may be required to keep a part of massive storage outside the building. That means the storage device for fulfilling these two work, the storage device should be outside of the building. Okay, here here also the storage device is outside of the building. Okay, then for the purpose of design, the physical input parameter that are required to be known are the daily sum of global radiation in inclined surface. Okay, the interaction of solar radiation with opaque and transparent surface, radiation exchange between building surface and the surrounding, and the heat condition in a wall, periodic variation of outside temperature. That means for purpose of design, that means uh, for uh, getting our aim, these three aims, these for getting our these three aims. Okay, we can design our building in a such a way that it it prevent or it in uses solar radiation which is incident which is falling on our transparent surface efficiently, and reduce the losses by lesser and lesser. Okay, that is the concept of space heating by solar using solar energy. Okay, this is called passive space conditioning. Okay, Thank you.